Welcome to Flow Measurement Training. In this session, we will explore common questions and answers about industrial flow meters and their applications. Flow measurement is a key part of process control in industries like oil and gas, water treatment, and chemical plants. Accurate flow measurement ensures safety, efficiency, and quality in operations. Throughout this training, we'll use a Q&A format to make learning simple and interactive. You'll see different types of flow meters, like turbine, magnetic, ultrasonic, and differential pressure meters, and understand where and why they are used. So let's get started and make flow measurement easy to understand. Question 1. What is flow measurement? Flow measurement means quantifying the movement of bulk fluid. This could be liquid, gas, or steam, through a pipe or channel. Why is this important? Because accurate flow measurement is essential for process control, monitoring, and safety in industries. Without proper flow measurement, processes can become inefficient, unsafe, or even fail completely. So in short, flow measurement helps us keep operations smooth, safe, and cost-effective. Question 2. What are the types of flow meters? There are several major types used in industries. Let's list them. Differential pressure. Flow meters. These are the most common and work by creating a pressure drop across an obstruction electromagnetic flow meters. Ideal for conductive liquids using Faraday's law of electromagnetic induction. Coriolis Flow Meters. These measure mass flow directly using the Coriolis effect. Vortex Flow Meters. They detect vortices created by a bluff body in the flow stream. Ultrasonic Flow Meters. Use sound waves to measure flow velocity. Turbine Flow Meters. Measure flow by the rotation of a turbine blade. Positive displacement flow meters. These measure flow by trapping fixed volumes of fluid and counting them. Each type has its own principle and application, which we will discuss in detail in the next slides. Question 3. Where are differential pressure flow meters used? These meters are widely used in oil and gas pipelines, steam systems, and high-pressure utilities. Why? Because they can handle extreme conditions and provide reliable measurements even in harsh environments. The most common devices that work on this principle are Orifice plate, simple and cost-effective Venturi tube, offers higher accuracy with less pressure loss. Flow nozzle, used for high-velocity steam and gas applications. Differential pressure flow meters are popular because they are robust, proven, and suitable for many industrial processes. Question 4. What are the use cases of electromagnetic flow meters? These meters are suitable for conductive liquids. That means the liquid must allow electricity to pass through it. Where do we use them? Water treatment plants, for measuring clean water flow. Wastewater systems, ideal because they handle dirty or slurry-type liquids. Chemical dosing lines, for accurate measurement of chemicals in process control. Electromagnetic flow meters are great because they have no moving parts, so they last longer and work well in tough conditions. Question 5. When do we use Coriolis flow meters? These meters are used for high-accuracy mass flow measurement. Unlike many other meters that measure volume, Coriolis meters directly measure mass flow, which is critical in certain processes. Where are they applied? Oil and gas, for precise measurement of hydrocarbons. Chemical batching ensures accurate dosing of chemicals. Custody transfer of liquids, where financial transactions depend on accurate measurement. Density measurement. Coriolis meters can also measure fluid density along with flow. They are highly accurate and reliable, making them the preferred choice for critical applications. Question 6. What are vortex flow meters used for? These meters are best for steam, gases, and clean liquids. They work by detecting vortices created when fluid flows past a bluff body inside the meter. Where do we use them? Boiler steam measurement, very common in power plants and industrial boilers. HVAC systems, for monitoring chilled water or steam in heating and cooling systems. Compressed airflow, widely used in pneumatic systems. Vortex meters are popular because they are simple, durable, and can handle high temperatures and pressures. Question 7. Where do we use ultrasonic flow meters? These meters are used for non-intrusive and clamp-on applications, meaning they can measure flow without cutting the pipe or stopping the process. Where are they commonly applied? Temporary flow studies, perfect for short-term measurements during testing or troubleshooting. Large pipes, because installing other types of meters on big pipes can be expensive and difficult. Water distribution networks, for monitoring flow in municipal or industrial water systems. Ultrasonic meters are popular because they are easy to install, portable, and do not disturb the process. Question 8. What are turbine flow meters used for? These meters are suitable for clean, low-viscosity fluids, meaning liquids that are not too thick and free from impurities. Where do we use them? Fuel measurement, for accurate monitoring of fuel consumption. Cryogenic liquids, such as liquid nitrogen or oxygen, because turbine meters can handle very low temperatures, custody transfer, where precise measurement is needed for commercial transactions. Turbine flow meters are popular because they provide high accuracy and repeatability for clean fluids. Question 9. What are positive displacement flow meters used for? These meters are used for highly accurate volumetric flow measurement. Unlike other meters that estimate flow based on velocity or pressure, positive displacement meters measure the actual volume of fluid passing through. Where do we use them? Oil dispensing, for precise delivery of lubricants and fuels. Chemical batching ensures exact quantities in chemical processes. Polymer industry, where accurate measurement of viscous liquids is critical. Positive displacement meters are chosen when accuracy is the top priority, especially for billing or critical chemical processes. Let's summarize what we've learned about flow meter selection by application. Differential pressure, DP meters, used for steam, oil, and gas pipelines, and utilities electromagnetic meters. Ideal for water treatment, wastewater, and chemical processes. Coriolis meters, chosen for oil and gas, custody transfer, batching, and density measurement vortex meters, best for steam, HVAC systems, and compressed air. Ultrasonic meters, used for large pipes, water networks, and temporary measurements. Turbine meters, suitable for fuel flow, cryogenic liquids, and custody transfer. Positive displacement meters, perfect for oil dispensing, polymers, and chemical batching. Each type has its own strengths, so selecting the right meter depends on the fluid, accuracy needs, and application. Thank you for attending this training session on flow measurement. We hope this Q&A format helped you understand the different types of flow meters and their applications in industry. If you have any questions or need further clarification, feel free to reach out. Stay safe, keep learning, and see you in the next session.